All right. Good morning, everyone. I hope you are doing great. It was a great keynote session, so I'm guessing that everyone is warmed up now. Okay. So this is Mohammed Saeed. I'm a senior electrical engineer at the California Energy Commission, and today we are going to talk about the evaluation of all electric homes, especially what is the cost of electrification, in real prices, in terms of real prices, and we will use like two tools which are openly available. CBECC, as all of you might know, it's free and can be obtained through Wilcox website, and the NBT tools, which we are going to talk about today. Okay, so the outline is that we are going to do some very brief introduction of the CBECC NBT tool. NBT is the net billing tariff model. And then we will talk about how to obtain the 8760 hourly data, 8760 hours in a year from CBECC. We will use Climate Zone 12, and we will use 2100 square feet prototype model. And we will use the PG&E example as a tariff. And then we will see that how do we find the exact cost of electrification for our new construction house, right? And then our staff has spent some time in doing the calculations, for all climate zone for 2100 square feet, in which you can see that how the annual cost of electrification varies per climate zone. Using the standard PV size, which is a very small, as you might know, and then we will see that if we max out that PV, how much cost of electrification will basically be saved, right? And we will go there. So let's get started on that. Okay, so first of all, you are pretty much, most of you will be familiar with 2022 NBT decision by CPUC, the net billing tariff. Before that, we used to have the NEM 2.0, in which exports were pretty much compensated at the full retail rate, and in 2022 decision, they went from the full retail rate down to the ACC value, export rate, which we will talk about. So, and this is the website. You can simply put net billing tariff CQC and you will reach there. And in the bottom of that web page, you will go to this analysis tab. And once you click that, you will see a very beautiful spreadsheet, very lengthy, very complicated. You might spend like 2 to 3 days just to see what is it. But E3, which is the consultant, has done a very beautiful job. And the credit goes to them, and under the leadership of CPUC, and they have created the legend as well about each cell in that spreadsheet. So, and this spreadsheet is really great if you want to see the real big impacts. Next one. So, some of the highlights of the tabs, there are like, I think around 20 tabs, but not all of them are important for our discussion today. The first one is the dashboard tab, and you will see that you can pick up the utility, the 3 IOUs, and you can pick up the climate zone. And the climate zone is really important for determining the export rate. I think they do like inland and coastal for each of these utilities. And then there are results tab, where we will get the bill savings, post solar bill and pre-solar bill, and they use the counterfactual. In that one, and the customer bill components, in which we will get the nitty-gritty, that how exactly each bill component is calculated, right? We don't need to do much in that one. The hourly data is the most important tab, and we will spend some more time once that slide comes. That is where you will have to paste the data from CBECC's hourly results. Export rates, again, no need to change. However, it will really help you understand how does that get calculated. It's based on the weekday, weekend average of the audit cost calculator. Minimum bill, really, you will have to look at your current IOU tariff, and you will fill that out in that minimum bill tariff. Avoided cost, again, it has the ACC values, I believe, up till 2050 or around that, so no need to change. Import rates, again, we will spend some time. This is where you will have to check what is your current IOU tariff. And similarly, the customer charge, like it will have like a daily charge or so. Okay, so first thing first, we will have to get the data from our CBECC res. Now it has become CBECC. So as soon as you run the CBECC file, it generates two files. It has one is a standard XXS is the name of the file that you have put. So the standard hourly result file and the proposed hourly result file. Standard file basically what the standard design is, and the hourly results for the standard design, and the prop and the prop is for the proposed design. So as you know that the current standard design of the new house for 2025 is basically 2 heat pumps. So so you will get that. It's a month, day, and hour. And for each of the load, it goes all the way to the 8760. And then it has PV. So in the next slide, you will see that we will mostly have to sum this up. It does not come up with a sum. And the PVs are the negative values. To use that in that NBT tool, we will have to multiply that by -1 or do the absolute function, whichever you like. So this is the standard hourly results. Okay, so standard, as you know, is the standard model consists of heat pump, water heater, and the space heater. And for this example, we are choosing the gas cooktop. You can use the induction as well. From the CBECC, it's up to you. So I have named the file as this 2022 climate zone 12 2100 square feet standard hourly results, right? And I summed up all the loads, and then I use the absolute PV value. And in the next slide, you will see that I will copy these two columns and will put that in the hourly results tab. Okay, so this is for the standard design, and just to see the impact of electrification, I would use another model called the proposed model. I will put the name gas here, right? So it has the gas water heating, gas space heating, and the gas cooktop, right? The completely normal mixed fuel house here. Okay, and similarly, I will do the same stuff. I will sum up these loads and will use the absolute PV value. Okay, now look at the NBT spreadsheet now. So this is the spreadsheet you have. You can change, the IOU. For this example, we are using PG&E 2025 adoption year. Where the PV is being adopted, and it's a non-care, it's a solar residential, and it's not a BN customer. And as you know, climate zone 12 is inland, it's not coastal, and we are using the NBT rates. E-elect is the name of the post-solar tariff. And as you might know that there is no ACC value adders, right? If you remember in the NBT decision, there were ACC adders which basically goes down in the coming years, but for new construction there are no adders, so I have put 0 here. Okay, so this is the most fascinating tab. It's the import rate tab of the NBT tool, right? This is a very playful one. You basically put the new tariff from the PG&E tariff sheet, and then you have to make sure that usually it stays the same, but you can double check that which one is the off-peak, on-peak, partial peak for summer, winter, and you can all change from here. Make sure that the code aligns with this spreadsheet here. Similarly for the post-solar as well as from the pre-solar tariff. Now this is where the magic happens actually. So we get the data from the CBECC res and we paste it here, okay, in the hourly data tab. And then everything gets calculated automatically. There is one thing that few people might know, there's a no netting true up concept in the NBT rule. So this is a very complicated concept, and when I came to know about this for the first time, it was really I really couldn't understand as well. So what this non-netting true-up concept is, as you know, in the NEM 2.0, when you were doing the netting across the whole hour, since you were getting paid same, whether you are importing or exporting, you were, even if you were truly, let's say you were importing for the first 5 minutes and then you were exporting for the next 10 minutes, you know, even if you were netting across, it won't have a very different. But now, since your imports and exports are now getting calculated separately, now we have to do, CPU says that you will have to do the non-netting true-up. And the way it gets calculated is that you will have to have an adjustment factor, which is around 6.6%. So you take the hourly 6.6% of that, you add that in the exports, and that same kilowatt hours, let's say it was 100 kilowatt hour, right? In that hour, hypothetically, you get 106.6%. That 6.6% kilowatt hour will be added into your exports, and that same one will be added into your imports as well. So that is how they kind of make sure that you are not getting less compensated for the exports in that hour. So that's how the CPUC has come up with. And the adjustment factors are published by each IOUs, PG&E, SCE, San Diego Gas and Electric separately. Okay, and after doing all the calculation, we get the results tab, in which we kind of see that, let's say for this example, we are only saving $66 in the first year of putting solar, right, for the heat pump. Okay, so now how do we find the electrification annual cost, right? This is what we want eventually. So we run both models, the standard 2 heat pumps and the one mixed use, right? And then we use the NBT calculator to get the pre-solar, which is the counterfactual bill, and the post-solar NBT bill for both cases above. And the annual cost of electrification without PV and with PV, we have to do two calculations. One is, I'm saying A, and the other is B. We are doing the pre-solar annual bill, right? Standard mode, you know, model, standard design model, and we then subtract it minus pre-solar annual bill from the mixed use model. Okay, and then we get that if we don't put the PV, how much will be the difference in electricity bill will be? It's called A. And then the annual cost of electrification with PV, we will do the same, but with PV. We will do the post-solar annual bill, which is the standard design model, and then we do the post-solar annual bill, which is the mixed use model. We are calling it P. And the annual cost of electrification reduction by PV is A minus P. Why? This one had, the gas model had the, the gas furnace, the gas water heater. That will get, subtracted out once we do that. And we will only have the cost, which is the heat pump heating and heat pump water heating. Okay, and that is what we want as the cost of electrification. Okay, so the staff has, the staff has run some numbers across all the 16 climate zones with different IOUs. As you can see, like 16 climate zones, some of the IOUs are being shared with one climate zone. Because as you know that a few climate zones or the few IOUs are torn between few climate zones, so we ran few different scenarios. So as you can see here, with the standard design kilowatt in climate zone 1, and you know that climate zone 1, to recap, has a lot of heating load. It's cold, it gets cold out there. So the annual cost of electrification with PV is basically $500, right? So what it means that if you switch your house from mixed fuel to the all electric, the annual cost becomes like $500, and that is very small as compared to here in climate zone 15, right? In Palm Springs, I believe. So the Palm Springs area is climate zone 15, and the electrification cost is 73. Why? There is only cooling load there. I don't think so anyone is heating anything in Palm Springs area. So that's why it's $73 there, right? And you can run, you can see that San Diego Gas and Electric has more cost, than SCE and PG&E. So it really varies with the tariff and how much PV are you putting there. Okay, now, should we increase the size of the PV, right? That's the question that we get as well. So let's see the example of climate zone 1. In climate zone 1, with the standard design PV, the standard design PV was almost 2.954 kilowatt for 2100 square feet home. If you want to max it out, you can go all the way to 6.73 kilowatt. More than that, the CBECC might not run or might not allow it because we have a cap that you cannot size your PV more than your annual consumption. So you can more than double the size of PV, but your annual cost of electrification reduction basically only goes from $500 to $894. So even by doubling the size of PV, you are not exactly doubling your PV cost, your electrification cost reduction. So basically the idea is we should not oversize the PV, right? Otherwise you are paying almost a double, but you are not getting the doubling of the benefits. Similarly, you can look at example of climate zone 12 that we discussed. We go from 2.69 kilowatt to 4 kilowatt, and the savings only go from $239 to $407. Sure.
The reduction is relative to no PV, all electric?
No, it's the annual cost of electrification. So both are the PV. It's that the so the way it is calculating is from the mixed fuel design with PV. Yeah. So basically, it's saying that if you have a house with a PV in the standard PV and you have a mixed fuel house, you are paying $500, right? Okay. Okay, so and let's see one more example in climate zone 15, which is very rare Palm Spring. Even if you are going from 4.75 to 5.22, you are going from $73 to $119 for the reduction in electrification costs. So that's pretty much it. Small presentation. Any questions that you have?
Mohammed, you haven't run this with battery storage yet, right?
Yeah, because battery storage is not required for single family. We can run that with battery storage, but and the reason we don't have the battery storage yet in our standard design is the cost of battery is not coming down, and with now ITC going away, it will take some more years on code cycles before we can have the battery storage in the code.
The payback analysis for rooftop solar, even when like the standard size of then increasing and doubling it, it's still a 20-year payback with NEM 3. I mean, it's still really, really long.
Exactly. Even if it might be that if you double the size, that the payback might increase because most of them are going into the exports. And the NBT says that if you are not using the PV and sending it back, especially in the afternoon, the off-peak hours, you are only getting 1/3. That is what the NBT is saying.
Have you run with this because you're showing the reduction? Are you also running the total cost of energy?
Yes. So the way the reason I did not focus more on the total cost because we were just focusing on the the operating energy cost of the heat pumps. Right, so that's why I subtracted them out. But yeah, if we do that, we can definitely get the results from the total bill as well. But here I wanted to focus more on the heat pump portion cost because that's Many people think that if we do the heat pump, then basically we are paying now in electricity. So that is where PV comes to the rescue. Because if you are using PV and with a heat pump, especially if you use that during those off-peak hours, you basically save a lot. Because you have to make sure that you don't export. Anything exported before 4 or 3 p.m. it's getting 1/3 of the compensation of what you could have.
Right.
Got, yeah. Any more questions?
Yep, Mohammed, one more. Where do you see the market for this tool? I mean, last year, like Will was talking about putting ratings onto existing homes. Is that, and I think the goal with that was to use CBECC as the tool. Is this a step in that direction?
So yeah, our office is pretty much against using the real rates as any sort of evaluation because those are not the correct criteria. We have our LSCs, the long-term system cost, because rates change every now and then, right? However, this is a tool basically you can use, the consultants can use to basically if the client is asking, okay, I will do heat pump, but tell me how much my customer is gonna pay every year more than the mixed fuel. So that is where these tools, the NBT and CBECC come into play. Yeah.
Okay, so then can we? I don't want to. Other people have questions here, but can we use it as a design tool rather than it's either or in this case?
Yeah,
fully
you can.
electrified or not, but now I want to use it as a design tool to say, can I plug in a battery to show what would happen to their overall cost?
Absolutely, you can definitely use the NBT tool and plug on the battery, and it will, give you the results of the annual bill saving. You can use battery. However, compliance is still going to be based on LSCs. It's just for the sideways. If you want to know the real bill impacts, that is where it comes into. Yeah.
Thanks.
Any questions? Sure.
Can you explain how you got the reduction cost again?
Okay, sure. So yeah, this is what it is. So we run both. So we run both the standard CBECC model and the mixed fuel CBECC model, and then we use the NBT calculator, published by E3 and CPUC, and we find the numbers of the pre-solar. They are calling it counterfactual bill, and the post-solar, the NBT bill for both cases. And then we plug in both in this equation. Pre-solar annual bill with the standard model minus the pre-solar annual bill with mixed fuel model. So what it will tell you is the annual cost of electrification without PV, the equation A. And then you will do similarly here, the annual cost of electrification with PV equal to post-solar annual bill, which is the standard design model, minus the post-solar annual bill with the mixed fuel. Since the standard design model is going to be more because it will have the heat pumps, the cost of electricity bill will be more. So that's why it's on the left side. And then you subtract both of these, right? And once you will subtract both of these, what you will get is the annual cost of electrification by PV. These individual equations will tell you the heat pump operation without PV and with PV, right? And then once you subtract these two, then you will get the annual cost of electrification reduction by PV from the mixed fuel cost. Okay, any more? Yeah.
Has there been any studies done to validate the accuracy of the simulation model against actual field conditions?
I'm not familiar with any such study, but I think our prototypes, I know that we meet with our consultants like every other week, and we try to make sure that, like right now, we are trying to update our school models, and we are meeting with DSA every now and then. I think we have like weekly or bi-weekly meeting, and we are making sure that whatever they are designing, we are trying to, accommodate that in our prototype. So the accuracy of the prototype is actually what determines. But I would say that it's really close, but I'm not familiar with any such study.
I'm just thinking that what this is a comparative model,
Correct.
but not it's going to give you a percentage of effect.
Yeah.
It's not gonna give you a real number.
Exactly. Yeah. Modeling is an art. There is no doubt about it. All we can do is basically make sure that our hourly load data is accurate, and we do, a very good job in prototypes, and we have RJ here as well from my group, and he and his groups is doing an excellent job in updating the prototypes. Yeah. Here we use the 2100 square feet house, which I believe represent around 55% of the new construction houses being built in California.
This is based on CBEC res only right now, right?
Correct.
What about going into CBEC and doing other building types like?
Yeah, we can do that, and the NBT tool has both commercial rates as well. We haven't studied that, but yeah, the NBT tool has the commercial rates as well. So you can update the NBT for the commercial rate.
So if we want to run a multifamily housing project, can we use the NBT tool? Like if we're like arguing with people about a gas boiler versus a heat pump boiler?
Yeah, then that depends. So yeah, since they will have a VNAM, and then you will have to eventually we now with that, because then the VNAM is going to come into play, and then because there is no one bill for the multifamily. There are individual tenants there, and they each will get that credit.
Not necessarily. So
Mhm.
like in multifamily with a central boiler, the central boiler is going to be on a common area building, so there will be, we
Mhm.
run it as no VNAM at all, just
Yeah,
solar
that-
hitting common area meter.
Yeah, if you want to study only the common areas, then yes, then definitely we
Okay,
can use
great.
that model.
Okay.
But yeah, for the individual tenants, it gets really
We have this,
complicated.
we have the CBEC tool to run, or the QAC tool.
QAC tool,
To
exactly.
run the impact on residents.
Yeah,
But
yeah.
it's the common areas that there's a gap right now.
There's a gap. Yeah, we can definitely, do something.
Right.
Can you point out where you get the model?
If you go to the,
There's different versions, right, of it?
if you go to this, if you just Google net billing tariff CPUC, you will get the 2022 decision. And if you go into the bottom of that web page, you will see this paragraph, 2022 decision.
Oh, I see, okay.
And you have to click on the analysis.
Okay. Thank you.
Yep. Yeah, it's a very interesting spreadsheet created by them. This is the website you can take a look at. Any more questions?